Hello everyone, I'm Yang Zhiwei. Today I will introduce our recent work named Separate and Conquer, Decoupling Co-occurrence via Decomposition and Representation for Weakly Supervised Semantic Segmentation, which is accepted by CVPR 2024. Weakly Supervised Semantic Segmentation, WSS, with image-level labels, aims to achieve segmentation tasks without dense annotations. For example, given an image that contains banana, orange, and pineapple, etc., WSS intends to make pixel-wise predictions when the network is only told with the existence of targets. In general, to achieve a WSS task, it usually needs three steps. The first step is to generate class activation maps through a classification model. Terms give clues of the localization of objects. Second step is to leverage some post-refining methods, such as DenseCLF or PR, to conduct a refinement to camps. In this step, pseudo labels are generated from camps. The last step of WSS is to use the pseudo labels to retrain a segmentation model. With these three steps, WSS is competent to achieve dense predictions with only image-level supervision. Further, WSS can be divided into single-stage or multi-stage group, depending on the pipeline can be streamlined or not. Obviously, the quality of camps plays a fundamental role in the whole WSS task. However, co-occurrence widely exists in WSS and intends to incur false activation. For example, when we expect to activate the target marked by a star in the left figures, such as the boat train, the network cannot precisely localize exactly what we expect. Similarly, the seawater or the railway intends to co-appear with the target. Thus, they make an inevitable bias to the WSS and are usually false activated. To further explore the relations among categories, we visualize the relation matrix among 20 categories in Pascal VLC 2012. Dark color of each entry in the right figure means higher co-appear frequency. You can see that the co-occurrence is widely present in WSS and severely affects the performance. We contribute this issue to the fact that objects frequently appear together, while the limited supervision from image-level labels is incompetent to decouple such dependence. Considering that cropping images into patches separates the coupled objects and naturally avoids the false bias, we assume that the key to tackle this issue lies in separating the co-contexts. However, there are two challenges remained. The first is how to generate patches containing only one category to avoid co-occurrence. The second is how to recognize category at patch level and teach our model to differentiate the co-contexts. Cropping strategy tend to be tricky since the pixel level supervision is not available in WSS. Based on the above analysis, we propose a new training scheme named Separate and Compare to tackle the co-occurrence issue in WSS. As can be seen in the overview of our methods, the essential idea lies in initially separating the co-occurring objects before future extraction, and then enhancing category-specific representations to promote the discrepancy among co-contexts. Therefore, our method tackles this issue in both image space and feature space. We first crop the image into patches to remove the dependence among co-appeared objects. As can be seen in the illustration, an image with a person and horse co-appeared together is cropped into patches containing only person or horse. Then we design second encoder to extract multi-granularity knowledge from image level and patch level, respectively. With that knowledge, we formulate two contrastive losses to teach our model to recognize co-contexts at a fine-grained manner. Specifically, we propose to decompose the interior image into multiple patches containing only single category information. To this end, category tags from camps are designed for each patch, which help identify the co-contexts at patch level. We group the tags into three types: category tag, background tag, and uncertain tag. Only the category tag and background tag are leveraged to recognize patches. To conquer the context confusion and enhance the semantic representation, in future space, we design a dual teacher single student architecture to promote the discrepancy among co-categories. We first build a global teacher to extract category knowledge from integral images. The knowledge provides class choice for the students in patch representations and helps to push apart co-contexts. Considering the trade-offs between the separation of co-categories and the distraction on global contexts, we shared encoders of both global teacher and students branches to provide complementary information for patch and image semantics. In addition, patch semantic knowledge is further extracted from a patch-level semantic reservoir maintained by a local teacher. Guided by the tags from memory pool, the knowledge helps remove the bias during the representation and pushes apart co-context while pulling together those within the same category at a fine-grained level. Finally, along with the category tags and the extracted knowledge, multi-granularity contrast is further proposed across the whole dataset to decouple the co-context deeply. Here, we represent the visual comparisons of our methods over recent WSSS methods, AFA and TOCO, from the quality of camps and the semantic masks. It can be seen that SECO precisely localizes the core categories and generates better camps with much fewer false activations. It improves the semantic performance by reducing the false positives from co-occurrence issue as well. Further, we visualize the category knowledge from global teacher in the top-level figures. It shows that the image-level knowledge extracted by SECO is totally separated, which helps promote the difference among co-contexts. We also demonstrate and demo that the SECO can recognize co-occurrence at a fine-grained manner. As shown in right figures, we crop 16 patches from a demo image containing both table and chair. We compute the similarity between each patch and the corresponding image level category knowledge. This shows that SECO can successfully recognize context instead of being biased to chair or table. In general, SECO is a novel single-stage WSSS scheme to tackle co-occurrence issue without any extra supervision and with more efficient and better performance. Thank you for listening our talk. You can get more details by scanning this QR code.